हाय फ्रेंड्स, मैं हूं आपका दोस्त समी और आज का जो हमारा डिस्कशन का टॉपिक है वो है मोमेंट ऑफ इनर्शिया। सो बेसिकली व्हाट इज मोमेंट ऑफ इनर्शिया? Moment of inertia, it is basically the resistance offered by a body to the external force or energy. If we take a look on Newton's first law of motion, it says that every body continues its state of rest or state of motion until an external energy is applied onto it. Consider one example. There is a body which is resting on the ground, and it continues its state, right? It does not move from one place to other, right? Until we apply an external force on that particular body, right? So that's basically the concept of moment of inertia, right? So there are two types of moment of inertia, that is mass moment of inertia and area moment of inertia. Let's take a look on what are those concepts. Mass moment of inertia, it is basically the product of area of it is basically the product of mass of a small element and its distance from the axis of rotation, right? So consider a body of arbitrary shape, and it is divided. Suppose it is divided into n number of elements, right? So that particular small element has a mass dm, right? So the moment of inertia of that particular element, it is basically the product of mass of that particular small element and its distance from the axis of rotation. Similarly, with the area moment of inertia, just the mass, it is replaced by the area, right? Now the area moment of inertia, it is again divided into two types, that is the first order moment of inertia and second order moment of inertia. Now for explaining these concepts, let's take one arbitrary shape which I have taken over here. Suppose it is divided into n number of elements, right? And suppose each element has a mass dm and area dA. Now the mass moment of inertia for that particular body can be mass moment of inertia of that particular body along the axis x dash, right? Along the axis x dash, that is very important, because the mass or the moment of inertia, it is it depends upon the axis. It depends upon the axis onto which we want to find out the moment of inertia, right? It changes from axis to axis. If I take this as my axis, vertical, then it will be different. For this horizontal axis x dash, this will be, the moment of inertia will be different, right? So let's take this as my element, right? So this element has a mass dm, and let's take the distance of that particular element from my axis of rotation is y, right? Now the ix dash can be written or can be find out by using this formula, integration of y square into dm. This is my mass moment of inertia. And for the area moment of inertia along the same axis ix dash is y square into dA. So that is basically the concept of mass moment of inertia and the area moment of inertia. Similarly, the first order moment of inertia can be find out by using this formula along the x dash axis as y into dA, right? And the second order moment of inertia can be find out by using the formula integration of y square into dA, right? So it is basically the second order of the distance of that particular element from the axis of rotation, and here it is first order. That's why it is called as a first order and the second order moment of inertia, right? Now let's take one example. Through one example, we can understand the moment of inertia concept very well. Let's take a rectangle over here. Let's take a rectangle, and what we will do, we will find the moment of inertia for that rectangle. This is my x dash axis, and this is my y dash axis, right? So in the previous page, we have seen one formula, that is for the horizontal axis ix dash, it is y square dA, the second moment of inertia. And if I want to take for Iyy dash, so that will be x square into dA. Right. So now let's find out the moment of inertia for both the axes. Right, for both the axes we will find. So for ixx dash, what we will do, we will consider one small strip over here. We will consider a small strip over here which has I've forgotten to give the dimensions over here. This is my breadth, this is my breadth b, and this is my depth d. Right. So now I have considered one small strip over here which has a thickness what I can say dy, right, and its distance from my axis of rotation is y. Let's say y. Now I can find out the ixx dash as y square into dA. Right. Now here the limits are very important. This is my depth d. Right. So this half will be d by 2 and this will be d by 2. If I consider this as my reference, so this the limits will be minus of d by 2 to d by 2. If I consider this as my reference, so this distance is d by 2 and this also d by 2. So this will be 0 to d by 2 and this will be 0 to minus d by 2. So the limits will be, we have to take the whole moment of, we have to take the moment of inertia for whole area, no? So that's why the limits will be minus d by 2 to plus d by 2, right? Okay. Now, right, the integration minus d by 2 to d by 2 and y square into dA. So dA will be here b into, b is my breadth and thickness of that particular strip is d into y. Right. So now let's take the b outside because it is a constant. Integration of minus d by 2 to d by 2 to d by 2 and y square dy. Right. Now the integration of y square is y cube by 3 from minus d by 2 to d by 2. Right, the limits are minus d by 2 to d by 2. Now the 3 I'll take common, I'll take outside, and y cube, it is d cube, we will put the limits over there, d cube by 8 plus d cube by 8. Right. So what will be the result over here? B by 3 2d cube by 8. Right. So ultimately my moment of inertia over here is bd cube by 12. Right. So this is my moment of inertia for the axis x. Now what we will do, we will find the moment of inertia about this y dash axis. Right. So I y dash will be x square integration x square dA. Now the limits over here will be same as that of the prior case, minus b by 2 to b by 2 if I consider this y dash as my reference. Right. So minus b by 2 to b by 2. Now consider the thickness of that particular strip as dx. Right. Consider as dx, and that d is my depth over there. Right. So minus b by 2 to b by 2 x square, and dA will be what? Dx into d. So d I'll take common, and the integration of x square will be x cube by 3 minus b by 2 to d by 2. So d by 3 x cube. So I'll put the limits over there. B cube by 8 plus b cube by 8. Right. Now what we will get over here, d by 3 2b cube by 8, and ultimately it is db cube by 8. So this is my I dash. Right. So this is as simple as that. This concept is very simple if you understand. Right. So thank you for watching, and if you are not if you have not watched my fixed line moment video, then please go to the description. You will find the link over there and you can watch that video. Thank you.